you see something, let me know. Coolness. All right. So let's see. Let's do one like, yeah, let's do this one. Now, if I ask you to describe this very quickly, describe what this does quickly, how would you say it? All right, so be a little more specific. Does it look like a parabola? Does it look like a V? So below -2, it looks like a line, good, with negative slope, right? So below -2, it should have negative slope. So it should be approaching something like that. And above -2, it should always be 5. Right? So you go into this knowing kind of like what's supposed to come out. Now that's not good enough to just draw something and say it's a line until -2 and then it's straight and that's good. No. I mean, you got to, the right way to do this, the best way to do this is make a little table of values for each situation, right? So for this one, you can only use values below -2. So what's weird is I don't want to just start at -3. I actually want to start at what? -2. Yeah, and then some of you guys are like, well, you're not allowed to use -2. I know. Plug it in there anyways. Because otherwise I wouldn't know where to put what. So some of you guys are looking at this and starting at -3, and then there's like space in the middle. And I'm looking at this, why couldn't I use -2.1? Why couldn't I use -2.03? I could use those. There should be a big old space. So you do plug -2 in just to see where the open circle goes. So when you connect it, you do use all those values that you're allowed to use. -2.8, -2.7. I'm allowed to use those, right? Yeah, exactly. I just can't use -2 for real, but I'm just going to plug it in just to see where it wants to be. So I know where to put that open circle. So at -2, of course, where's this want to be? 3. Yeah, if you plug a -2 in, you get 3. It wants to be at -2. 3 is where it wants to be. And then in -3, it would be at 4. -4 would be at 5. That's amazing. All right. So there's your straight line activity, right? How we doing so far? And then you use another one for at least -2. So now I can use -2. -1, 0, it doesn't matter. What's the output? 5, always 5. Yes, sir?
And when you graphed it, you would just put where the open circle was for the first one, it would fill it in.
Well, let's see if it does. I can't, it doesn't always happen. First one we did, it didn't, and the second one we did, it did. Right, so it doesn't have to. Who cares? The two don't have to agree. For it to be something that makes sense physically, it probably would need to agree. Right? But these don't have to make sense physically. Let's see, blah, blah, blah. Yummy scale. So at -2, it wants to be at 3. So it wants to be there. At -3, it can be at 4, and so forth. So that's like that. So is that a downward slope?
Yes.
Yes, all right, so far so good. And that line is supposed to stop at -2, and it does. It stops right before -2, like it's supposed to. Cool. All right, I like it. Do you guys see this? Some of you guys try to, I don't know if you think you're, I don't know. I mean, you don't have to do this. You can actually do this without all this work.
But it helps.
But it helps, yeah. And it helps me make sure that it's coming from the right place. And then for this one, all I do is, at -2, it's 5, and then it's 5 forever after. Right?
Yeah.
Sweet. Cool. So I saw a few too many arrows here and arrows there, and then I'm like, well, now it doesn't pass the vertical line test. Now you made it not a function. That's bad. Okay. All right. Is that decent? So there's that problem where there's 3 parts to it, and there's a parabola in the middle. But again, you just do what we just did. And you cannot go wrong. If you only plot the points that you get from your tables, it's almost impossible to go wrong. Any other questions on piecewise functions? This is the day to do it. Tomorrow's the test. All right. Okay. 2D. All right, cool. Looks like this here. Is this one? 3a squared?
Yes.
Some of my colleagues teach this differently, but I think order operations is a good idea to follow, even though you don't actually have to here. But still, what would I say you should do last?
Square.
Yeah, the negative 2 power. I do that last. I'm going to simplify the inside first so I've got less shit to do this to. To me, it just makes sense. I have colleagues that say bring this in first, but then people freak these out. And I don't have 3 over 12. I don't want to square 12. What is 3 over 12? See, so if you reduce it and gather stuff together, there's less crap to do this to. It only makes sense to me. There's other ways to do this, though. So what do you get on the inside? Here, like you said, we get the 3 and the 12, like it's 4. What happens with the A's? Which one moves? Yeah, these 5 don't like it. They're going to go up there. There's already 2 up there, so how many's up there now? 7. So don't make more of a deal than that. That's it. The official, by the book way to do this is 2 minus negative 5 is positive 7. Right? That's because you subtract powers when you divide. To me, that's just stupid because I'm going to do that in my head. I can make a negative mistake very easily. I totally could. We all could. So I'd rather just get rid of my negatives. I'm not going to make a negative mistake if there aren't any freaking negatives, right? What happens to the B's?
4.
Good. Those 3 go down, so then I got on the
B4.
On the bottom. Does that make sense? There's 1 B down there, he's liking it, and then there's 3 more B's coming down there. Alright, and on the outside we still have. So what's the negative part tell you to do?
Square the reciprocal.
What's the negative part tell you to do? Flip it, and then you square it. Cool. So when you square that, you get 16, B to the beautiful, A to the 14. Now let me see. When I first teach this, way back in like Math 90, I have students who don't understand. And this is the part that I try to get people to understand. If you think math is changing, if you say to yourself, we didn't do that before, now we're doing something different. If you ever catch yourself thinking that, come see me immediately because you're wrong. You're not looking at it correct. Math can't suddenly say, now we're not in chapter 2 anymore. Now negative power means it's right it sideways. It can't. Do you understand? This is something really weird for students to get down because it feels like, well, we didn't do that before. Now we're doing it. I don't know why. I'm just going to do it. You're not thinking about it correctly. So, for example, here, I squared this 4. Why didn't I square that 4? People are like, Jeff, what the hell? I only have 1 4 in this whole thing. It's right there. What does this 4 represent? Yeah, so it's 4 B's, right? So if I had 2 groups of 4 B's, I now have 8 B's. So that's not a 4. That's where people like, I lost all respect for you. That's a 4, man. That's the basic thing you got to know about math. But I'm like, that 4 doesn't mean 4. That 4 means 4 B's. If I wrote 4 as 2 squared, if I wrote this in the same format, math would do the exact same thing. 2 times 2 is 4. 2 to the 4th power is 16. Math doesn't do different things to these. It's because these are in different formats that they don't act the same. That's the kind of thing I'm talking about. That's a really fine line. That's where people lose faith or feel like they don't know shit. And math is like, we didn't do that before, we're doing it now. When do I do it? Oh shit. Well, no. It's doing the same thing. It's doing the exact same thing. They're just written in different formats. Cool. Maybe. Alright, so let's see. That's 2D. Any questions on that? Little dude there. Alright. So 11D. Oh yeah, 11D is yummy. Sorry. That's my... I'm the only one in this room that would say that. 11D. I got a different adjective for that, Jeff. I love this problem. So if the problem is all about factoring, I will almost never be multiplying stuff. So, dear God, don't square this and FOIL this out. Oh my God. Dude. That would be if the problem said simplify, right? And that means carry out the operation. So there must be something I could do. How many terms are up there? No? 2. There's a single plus in the middle of that and that. There's 2 terms. I can really only do something if they both have, if it's a GCF. Do they both have something, obviously? There's nothing obvious about them, right? But what can I do with this first dude that's in the spirit of factoring?
I can factor out a 3a.
Now, if I do this, it's not right. So I've done something wrong. Because how many of these do I have? 2. So if I take a 3a out on one of them, I better take a 3a out on the other one. I take a 3a squared out. Oh, shit. So for example, this kind of thing shows up in a lot of different places in mathematics. If I had this, you could do it, Jeff. There you go. And I try to factor out an x squared, what am I actually going to put in front? I'm not going to put x squared. X, because, and let's assume that x is positive, just get past all the other shit. You with me? I can take an x squared out, but the square root of x squared is x. And then be left with 1 minus x squared. So I can take a 3a out, but 3a squared is 9a squared. And then the other thing I can't do a damn thing with, which is fine with me. And now, what do they have in common? Yeah, they got some x minus 1s, they have some a's, right? And they have some number stuff, right? Cool, now you can attack that like the one we did somewhere. I can't remember if there's warm-ups or where it was. So what number can come out? 3. How many a's? 2, good. How many x minus 1s? 2. I like it. So then what's left here? I took both of those away. I took both a's away. Which is just a 3. I love it. You guys see that? Good. All right. And then plus 4a to the third. How many of these left? 1. And then you just distribute that. That's the last step. That's one reason why you have to multiply when you factor, because maybe inside one of your factors you can simplify it down a little bit. You still do that, just like we did on whatever that was. I can't remember where that was. Was it the first quiz? Yeah. What's up? Where am I? So you're good to here?
No, just before that.
Okay.
Yeah.
So now,
I tracked you as far as 3a squared out, and then.
All right, 3a squared. And why did you take 2a's out?
Because I've got at least 2 a's on it.
Good. That's the lowest power. So how many x minus 1s can you take out? 2. Same reason as the a's, right?
Okay.
So that's exactly what I take out.
I had the wrong exponent.
Oh, okay. All right. Yes, ma'am.
I don't understand what we got the second 3 plus 4.
Oh, this guy.
Yeah.
All right, so here's the first term. So that's going to be the leftovers of the first term. There's the second term. That's going to be the leftovers, right? So what's left over? I took both x minus 1s out. I took both a's out. I had a 9. I factored a 3 out, so now there should be a 3 left.
Okay.
So that's all we do. You figure out what the GCF is, and then you write the leftovers after you divide that out of each piece. Right? Because that's the opposite of multiplying it back in. Right? Is that cool? Is that understood? All right, good. A few more of you shook your heads. You didn't like the word cool. What it meant was, is it understood? You know, like, that ain't cool, man. That's something else. Yes?
At the very beginning, how come you took out 2 3a's? Instead of
because there are 2 3a's. So I really want this. Oh crap! I just lost. Where am I at? This was 11D, so I still got the web assignment. Okay. How do you write? What does that mean?
there's 2 of them.
2 of them. I love it. So if you just take out 1 3a, you still got the other one with all this 3a shit in it, right? So you got to take out 2 3a's. So 9a squared total. Okay. Because there's 2 of them. So if I had this here, what can I take out?
10 2x's.
Yeah, 10 2x's. And what would be left?
2x minus 1.
Good. 10 of those. For every one of these, a 2x comes out. So how many 2x's total come out? 10. I really want you to see how that is not a big deal in any way. There's just 10 of these dudes. So whatever you do to one of them, you do it 10 times over. There were 2 of these. So what comes out? A 3a. But it comes out of both of them, so you get 3a squared. That's all. Nothing major. Yeah.
Would it be, when you took out the 10, would it still be 2x? Because aren't there technically 12 x's?
12 x's.
Oh, no, never mind.
All right, catch it now. Yeah.
I just have a question number 10. I don't know what it's trying to say. 1 to 1.
Oh, I like it. All right. What's it mean for a function to be 1 to 1?
Yeah.
So to be a function, what has to happen? Passes the vertical line. Which you can put in words also, like the examples I gave on the quiz. You'd have to use more directly the definition for every x, there can be only 1 y, right? 1 to 1 means for every x, there can be only 1 y, and for every y, there can be only 1 x. It's got to go both ways. Which kind of makes sense then. It's not only a vertical line test, which is checking the x's out, it's also a horizontal line test, checking the y's out, right? That's why it's 1 to 1. Every x goes to y, every y goes to 1x. They're matched, right? So that's so nice. Valentine's Day coming up and everything. So to be a function past the vertical line test, to be 1 to 1, past the horizontal line test on top of that, right?
Which is one of the inverse of parabola is not a function.
Beautiful. So if I have a parabola, does that pass the horizontal line test? No. So if my function was x squared, then this would officially not be invertible. This would not be 1 to 1. Those mean the same thing. The word 1 to 1 means invertible.
But x cubed would.
Beautiful. X cubed would work because this falls out of the way, right? So x cubed would totally work. Wow. Because now it passes the horizontal line test. Check. It's 1 to 1. It's invertible. And its inverse, of course, is the cube root.
And the root of x.
Now, let's talk about that. The square root of x is what we know is really the inverse of this, but it's not really the inverse officially because the square root of x squared is not one thing. It's 2. Yeah, it's the absolute value, so it's one of those 2 things dependent. You kind of with me so far? So real quick, if I wanted to make this invertible, what would I do to this guy's domain? Because there are problems just like that in the homework. If I wanted this to be invertible, right now what's the domain? All real numbers. So let me restrict that so that it's invertible. So really, what am I saying? I'm saying take away the part that curves back on itself. You can erase anything up here you want to. Maybe not the whole thing, because then that would be kind of silly. The inverse of no function is no function. Right? But where do I want to chop this off at? Where do I want to... Yeah, if I took this part away, for example. If I restricted the domain to be 0 to infinity, now is this invertible? And its inverse is flip. That's why the square root is a parabola that's lost half of itself, because it had to lose half of itself to even be invertible. Let me say that again. A square root is a parabola that's lost half of itself because it had to lose half of itself to even be invertible. To pass a horizontal line test. That's an awesome way to look. So there are a couple problems in the homework that talk about that. There's a problem with like an x to the 4th plus 5. Is that invertible? What would that look like? X to the 4th plus 5.
It's even somehow.
Yeah, it could look like a W, but at least it's like this at the ends, right? This one actually doesn't have the little bumps in the middle because it's just an X4 that's been raised by 5. So it's like a skinny parabola. So is that invertible? Why not? Doesn't pass the horizontal line test. But how would you restrict its domain so that it was? So the problem in the homework actually says the domain is this. Is that invertible now?
Yeah.
Yes, of course. It's just like what we did here. They restricted it even more. They said you can only go up to 2, but that doesn't matter. As long as you cut it off. And I really want you to understand, could I have cut it off at 1 instead?
Yes.
Of course, that's still invertible. As long as you at least cut it off here. And you could have done it the other way around. Become the right, Jeff. It's way over there. There it is. So if I cut this half of it off, is it invertible?
Yes.
Yes. And that's the negative root answer. Holy shit. Right? Because the root, there are 2 square roots for every number. One of them is positive, and that's what we mean when we write square root. And one of them is negative. That's what we get here if I flipped it over. It would be the negative square root. Holy shit, there's a lot to ingest. But that's totally... Now, if you really wrap your brain around that, if I give you any function, you can kind of find a way to... So if I gave you this function, and let's say it goes like this forever. Can you guys see how to chop this off? Let me say this is a 1. So this is 2. Maybe 2. Is there a way to restrict its domain so that it's invertible? Negative. If I chopped it off here and there, is that invertible? Yes. Yes. And we basically just did an inverse trig. We don't even know that yet. Trig does this, right? So if I just chop off all the places that it repeats itself, that little piece now is invertible. Okay, that's going to come back and haunt us in chapter 5 and 6. Yeah.
Can you go over 8D on the practice test?
Okay. Are we all good with that? Is that cool? The one-to-one idea? So sometimes I'll ask you, draw the graph of a function that does these things, and that could be one of them. That isn't one-to-one. You just have to have it kind of go back on itself somehow, right? Wow.
After that, we do problem 66 on section 2.6.
So is it 8D, 66 on
Section 2.6.
2.6. Let me do the web assign question somebody asked me. Just from web assign, it said, it gave you this function, and it said, find the average rate of change between x equals, who did this one? I didn't write that much down. 0 and h. So find the average rate of change between those two. So how do you find the average rate of change of any function between 2 points? Find a slope, yeah. So it's really just f of h, in this case, minus f of 0 over h minus 0. So it's the y's over the x's, right? Nothing more than slope. It's crazy. So the whole section, if you can make things look like points, it's just finding the slopes. The entire section 2.4. What is f of h?
Over 2H.
Yeah, f of h would be 4 over 2h. Now, this is telling me that I wrote something down wrong. Oh, it's a 5 here, isn't it? Yeah, that's my bad. Whoever did that. That's a 5, that's my bad. So this will be, what's f of h? H plus 5. Minus, what's f of 0? 4/5. All over h. Are we decent here? If you've done 2.4 homework, this should look very familiar. This kind of problem. Of course, if you haven't, this doesn't look familiar. Bless you. So, what can I do on the top? What do I have to do on the top? Yeah, common denominator. So, I mean, they're relatively prime, right? Has anybody ever heard that? Relatively prime? 8 and 7 are relatively prime. 8's not prime, but 8 and 7 are because they share nothing. Does that make sense? So 20 and 23 are relatively prime because 23 is prime. That's pretty easy. These are relatively prime because they don't share anything. Don't tell me they both have a 5. This has a 5 and this has an h plus 5. So what's he need? A 5. What's he need? H plus 5. Cool. Am I changing the top? You see the top of the whole thing? Am I changing the top? No. I'm rewriting the top in a better way, right? So people are always like, well, why don't you do anything to the bottom? Because I didn't do anything to the top. I didn't. What's 5 divided by 5? 1. So I multiply by 1. Ooh, so I'll multiply the bottom by 1 too. Here. So then what do I get down up here?
20 minus 4h plus 20. Minus 20.
5 times h plus 5. Let me show you something. This is something you should, oh shit. There we go again. All right. What was that, section 2.6 and then 8D or something?
Yeah.
All right. I still have to have this over h piece here, right? For some reason, you guys, a lot of you don't know how to handle that. But if I had 3/2 over 2, that's 3/4. Bam, straight up. What's 3/2 divided by 2 is 3/2 times 2. Well, 1/2, right? 3/2 divided by 2 is 3/2 times 1/2. That's 3/4. The quicker way to look at it is 3 is being divided by 2 and then divided by 2 again. So it's being divided by 4 overall. So, you guys get this. This is awesome if you get this. If you don't, it'll still work. But that's being divided by that mess and h, so I can just write the h freaking right there. Now it's being divided by all of it, like it's supposed to be. It's the quickest way to simplify a complex fraction. If you don't like that, just multiply by 1 over h, like we did in class. That'll get you to the same damn place, right? Of course, what happens now? The 20s cancel. And of course, the h's cancel, so you get negative 4 over 5h plus 5. Is that cool?
What problem is that?
This is all Webassign.
Alright.
I just happen to see it. Okay, cool. Alright, so let's try these here. 8D.
Or would you put it 5h plus 25?
It should accept either one, but knowing Webassign. If you do something like this, if you put this answer in and it doesn't take it, and it tells you the answer was 5h plus 25, just send me the question about it. I can give you the points back. Right? I love Webassign because I can see all of your previous attempts, I think. And my Mac lab is not like that. It drives me crazy. Alright. And real quick, by the way, I see like 9 people signed up for Webassign, and about 2 people have done anything. So hopefully you realize if you've signed up for Webassign, you have to actually do it. Right? I don't know if you're doing it in a textbook and you just signed up for Webassign for something. I don't know. Right? So just be careful. It's due tomorrow.
I signed up for your class, but didn't know I had to pay money. So that kind of hindered me. I was just doing the book. Is that cool?
That's fine with me.
All right.
As long as I see it in one form or another.
Okay.
But right now, with the Webassign people, for most of them, I don't see anything. Online or in paper. So I'm hopeful about tomorrow. Tonight's going to be crazy busy. Alright, 8D, right? Well, let me do this real quick. Let me go ahead and give you guys the answer key. I always hold off on doing this just because. Just to remind you guys, if you overstudy the practice test, you're not doing yourself any good. So don't overstudy the problems on this. If you've done it a couple times and you still got it wrong, go find problems like it in the book. Odd problems so you can see the answer in the back. But if you overstudy this, then you know these problems. Gives you false confidence going into the actual test. You have to know problems like these, right? Because obviously tomorrow I'm not going to give you any of these problems. I mean, problems like these. Okay. I got to say that because the first time I ever did this, I had somebody really upset. And like, I knew your practice test backwards and forwards, and I got a D on your. I'm like, because I gave you a different test. I don't know what you want from me. So, okay, good. Yeah.
I have a question about the why this 5H? Why the 5H plus 25? I guess where you were subtracting the purple, turn the 5H multiplied in the denominator, multiplied by H plus 5, right below that.
Yeah.
Yeah.
Yeah, I just left it as 5H plus 5. I just left them separate.
Oh.
Which is what you always do, because the last thing you want to look at is see if anything cancels. So if you multiply the bottom too early, you can't see the common factors that cancel. So I just leave it factored all the way. WebAssign, you got to see if it's picky or not about multiplying that 5 through. It really should take it both ways. So let me know if it doesn't. Yes?
For number 4, how come the radius is square root of 61 over 2? Shouldn't it be the square root of 61 over 4?
Yeah, but what's the square root of 4?
2. But the square root, oh wait, no, never mind, think of 81. Okay, thank you.
Sure. I try to write in my best writing possible for this. So this is still messy, just realize that. This is my best possible. Thank you very much. I never hear that.
Well, compared to other professors.
Oh, I thought you were going to say compared to what you normally do on the board, Jeff. This is pretty good.
That's
Relative to that, almost anything is good. I feel bad for you guys. But, you know. So I am human. I have been known to make mistakes on this. So if you see one that you think is wrong, just let me know. Probably 8. But it could be. I'm averaging about a 97 on my answer keys. Which is good. It's pretty good. All right, let me see. Is that, who was asking the question earlier? Is that, did you see the answer key? Is that cool? Whoever asked? All right. Yes.
Number 4 of the practice test. The one the answer key seems completely different.
Oh yeah, all right. So on number 4, what form does a circle take? Something like this here, right? And inside here is going to be x minus h and y minus k. And this kind of makes sense because x squared plus y squared equals 25, for example. That would be what kind of circle? What's true about it? Centered at 0, 0. And the radius is 5, right? Whenever I do this, it looks like Stewie's head. Let's see what happens. All right, now that doesn't. It doesn't look like anything. Just deal with it. If I move the center, if I transform my circle, and let's say move it to 2, negative 3. I want that to be the center now. What's going to happen to my function? I want to move it positive 2. So what's gonna happen up here? X minus 2. I love it. And if I want to move it down 3, y plus 3. I love it. Cool. That would be a circle of radius 5 centered at 2, negative 3. Let me stop there. Do you see how transformations actually make sense as to why I can see certain things in the function that represents that graph? If I see negative 2 and positive 3, I know the center is 2, negative 3 because it corresponds to moving it there. Maybe. So, if I give you this function, what's wrong with it compared to what form it's supposed to be in to see stuff? Which variable is cool the way it is? X's because they're all together already. Are the Y's all together? No. Shit. So what do I have to do to this? Complete the square. Sweet. Like it. Some of us might have forgotten that process. Let's try it out. You ready? I'll tell you what. Before we do that one, let's just remember what completed the square is. All right, real quick. Right, because this is a really useful skill to have. So if I had, I'm trying to ask myself, what would I put here so that this factor is nice, like that. So if you think about it, where would that 8 have come from? Yeah, it would have come from 4 and 4. It could have come from 5 and 3, but then it wouldn't be the same thing. I couldn't write it like that. So half of 8 is 4. That must be what's here. And what's going to be there then? 4 squared. So this is the two-step process. You cut the middle thing in half, and you square it to see what goes there. So if I had something like this, let's do minus. Sure. What would I have to add here to make this factor nicely? Yeah, because half of negative 10 is negative 5. Negative 5 squared is 25. So 25 is what you have to add. If you add 25 out of nowhere, let's see if you guys get this. This whole Indiana Jones thing. If I take the little gold statue away, I got to put an equal weight of sand on there, right? And of course, he didn't quite balance his equation correctly. He didn't balance his equation correctly. Obviously, never took, All right, that's enough of that joke. If I add 25 here, I bet at the same time. So overall, what did I just do? Nothing. I just didn't do anything, right? Does that make sense by itself? Scheiße. Why do I have to put that plus 25 there? Because that's the number that's going to make this work. How would this factor? Yeah, it's going to factor like that. It's awesome. The first step tells you how the answer is going to look. The second step tells you what you have to put there to make it look like that. Completing a square kicks ass. Who remembers this? Who's ever done this before? A few of you guys. Does this sound familiar? This is it. It's the beauty of it. And it works because math is all about finding patterns. And this is exactly what happens in this case. It always happens that way. So then we use that to our advantage. Now, if I add 25, it's the same function it used to be. It used to be this. Not totally changed the function. It's not the same anymore. But if I do that, what did I just add? 0. So it's the same function. So I have to do that to make it the same. The whole thing about the scale. If I add 5 grams, I better take 5 grams away to make it the same. So I added 25, I better take 25. Now what does this look like? This piece is there. Minus 25. Where's the vertex? Think about the shifts. The vertex is normally at 0, 0. Where's it been shifted now? Yeah, it's 5. No, it's been shifted down 25. There you go, kick ass. That's why the general form of a parabola is x minus h squared plus k. Same reason as that. And that should not be a huge revelation. That's something you're supposed to come in knowing. That's the form of a parabola. But that's why it's related to transformations. I moved it over 5 and down 25. So now the vertex is at 5, negative 25, because it starts at 0, 0. It's nothing more than that. And you guys are all like, you keep saying that. I do not think it means what you think it means. Inconceivable. There you go. We'll be dead in a minute. Anybody want to do it? Alright, that obviously had nothing to do with the actual problem practice test, but that's just another example of completing squares. So the actual problem is this. So what's a good first step? Yeah, get 3 the hell out of the way. Make some room. Now what has to go here? What are the 2 steps? Always. Half of what's there. And then squared. So where's the 25 fourths go? Yeah, so I have to add 25 fourths there. I better add it on the other side too. That's why here it was add and subtract, because it was all on one side. There I can access both sides, so I just have to do the same thing to both sides, right? Maybe. So now how does this thing factor? Like that. Become a 5. So that, I got that from here, and then the first piece tells me what the factorization is going to look like. And they sort of kick so much ass. It tells you how to factor it. You don't have to factor it. It just says factor it like this. Okay. And on the other side I get whatever the hell that is, right? 61/4. That's right. So now I can see the center, and I can see the radius. Right? So if I put the circle in the right form, just like putting a line in the right form, I can see the slope and y-intercept. If I put the circle in the right form, I can see the center and the radius. It's kind of a nice thing about math. There's always kind of like a visual component hidden inside the work itself. It's awesome. Yeah?
It's a y, right?
This here?
Underneath the 25.
That's a 4. Sorry. Yeah, square of the 5/2. Yeah, my bad. Poor little 4 dude.
I thought maybe you just factored it out.
No, that would be really, really, really weird.
Where that y come from?
Roller coaster. Alright. Alright. Let's see. Did I forget anybody? Oh, yeah. Did we do this one? 6, 6?
Yeah, not 8 feet.
We didn't do 8. B?
D.
D. Oh, okay. So of course, whenever I have an equation with fractions in it, I can kill my fractions if I'm smart about what I multiply by, right? So I can multiply both sides of an equation by any damn thing I want to, except it's the only thing I can't multiply both sides of an equation by. 0, because then every equation would be 0 equals 0. We would all be living in caves, the whole story, right? So what the hell? What's the LCD? Yeah, because this guy, of course, factors to be these two, right? So then who needs what? What's this guy need? Of course, he's got it already. It's an equation, right? Just like when you show students what to do when it equals 0, all students want everything to be 0. That's kind of bleak. Everything is 0. Right? Very realistic. But the minute we show you can kill fractions, you try to kill fractions everywhere, of course, because we don't really like that. But this is an equation. That's the only time I'm allowed to kill them, if I have two sides to do something with, right? So if I multiply both sides by x minus 4, x minus 1, it cancels everywhere. So if you make all the bottoms the same, give whoever's missing something what they're missing. And the really ugly thing is when people don't factor this and they give this to both of these and they give both of these to this. Oh my God, that's disgusting. Then you gotta figure out how to solve something to a higher power, some crazy bunch. It's insane. And then you're angry at me. Why'd you give us such a hard problem? It wasn't that hard, dude. You made it a little bit harder than I wanted. So you have to factor first, see what the pieces are, see who's missing what. What do I have now? What's my equation look like now? Good. Plus 2x equals 3. Right? And of course, this piece tells you what to do. Since there's a higher power on the x in there, you got to get it equal to 0. In this case, it makes sense because it's an equation. Get it equal to 0, then factor and go from there. If you can't factor it, what would you do? Quadratic formula. Kick ass. Yeah.
On the paper, it says that when you simplify all of that and put the 3 on the other side, it says that it's positive 2x squared.
Totally, because they didn't put the 3 on the other side. Which one was this again? D. I brought everything to where the x squared. I brought, yeah, if my x squared's negative, I'm going to move things that way so that my x squared becomes positive. So I added 2x squared. I added everything over that way, so. Does that make sense?
Would it still work if you did it the other way?
Sure it would. Yeah, your a would just be -2. Everything would be off by a sign, so all those sign changes would cancel out. It would still work. Quadratic formula doesn't care what side you put things on. But just your whole thing would be a negative of mine. So that negative would cancel between the top and bottom of the quadratic formula, so you'd come out to the same answer. Okay, cool. I like it. I just like leaving my x squared as positive because then it's easier to factor. Yes?
Can you show the trick you used to solve 11C if you multiply the first and the second?
Oh, yeah. All right. And I really, well, anyway, I just don't like the trick there. It's just realizing that you have to take that 4 into account, right? And you're like, just do it no matter what word I use. So I'll say you said the word process. What process do you use? So you can't just find, you could find fractions -6 that make -5, but that wouldn't get you anywhere on this problem because that 4 screws that whole process up. So we made an entirely kind of separate process for this. You first have to take the 4 into account, right? How we doing so far? Is that a good first step? All right. Man, you guys don't want to give me anything. No emotions at all. All right. So now you want to find factors of that make the middle term when you add them. Yeah, -8 and +3. Kick ass. Now here's where a few of you guys, if you look at your homework where I graded it, I don't want you then to do the magic bullshit of dividing this by something and reducing and then just plopping numbers into places and you have no idea why it works. That's bullshit. Right? A lot of my colleagues don't agree with me. This is my class. I can make you do what I want you to. The funny thing is, that's the hard step. That's the hard part. If I wanted magic to come in, I want magic to come in before that step. Because if I make these numbers a little bit bigger, that step here could take me all frickin' day. You with me? Big ass number, you got to factor it and see what adds up to be the middle term. That could take a long time, right? I want magic there. Why have magic now? That's stupid. What do I do now? What do I do with -8 and 3? How do I use them? The one logic way. Yeah, just replace the -5e with 2 terms based on those numbers, and then I can group. That's what's funny to me, is that process doesn't even help. It doesn't make the hardest step easier. You still got to do that. But if right here you divided by, I can't even remember what it is, 4 is it?
4.
Yeah. And then reduced and put stuff back in, do you know why that works? Do you know why that works? Thank you. Actually, no. It's a valid thing, and actually there's a way you can explain why it works. But if you can't explain why it works, I'm not going to let you use it. No. Bye. So, -5b is -8b plus 3b. And then you can just group. Cool, right? Now everything, you can actually see where things are coming from. They don't just magically plop in. You want to see how I would do that problem? I don't know if you want to see it. I'll show you real quick. Hold on. So you get this here, right? You get a -2, 4b plus 3. All right. And that's what I call the surefire method, right? The way I do it is using something called the Texas slide, which is not a country line dance. Thank God. But real quick, I just want to show you. And this sort of relates to that magic bullshit. I rewrite the problem for a minute like that. Actually move it over there. Then you factor this. How do you factor this? Now, I can't stop there because this 4b squared, that's b times b. That's not right. Well, what I do is I move a factor. See how this 8 times b is 8b? All right, now watch. I need this to be a 6. So what should be here? So it's a 6. 2. So I move that factor of 2, and then I move that. So I move the factor of 4 down, and then I move a factor back to the beginning. I might have to do that in both places, though. So the more comfortable you are with playing around with numbers, the better this method is. And it's just because I get the same middle term. That's the key. If you don't like that, please don't do it. It's all right. I won't take it personally. It's weird. But the more comfortable you are with numbers, the quicker that is. And to be really honest, it's not entirely what I do. I do something even quicker than that. But it's based off of what this is doing. But I like that's where I start. All right. Let's see. Did I miss anybody? 2-6. Oh, wait, and you guys can finish this, right? I think this is when you have to use quadratic formulas, right? All right. Section 2-6. Oh, and then I want to talk about even and odd symmetry. It's a topic that I keep waiting for somebody to ask. Somebody finally asked me in my office earlier, so I'll figure out, talk about it. Right. So in the homework, if you hit something you're like, I don't think he's talked about this, ask it. Right? Because sometimes I'm waiting to see if people are actually doing their homework and reading the book. Man, you're a dick, Jeff. Yeah, that's too bad. So number 66. Oh yeah, this one's free. All right, good. This is the one about the airplane. Here's my airplane. It's more like Cliff Riders. This problem sounds so weird. The way that they're worded, but it's actually not bad. So the plane, we know the plane is going 350 mile an hour, I think. Yeah. And we know that it's exactly 1 mile above the little set, and it goes straight, so it's still a mile up, right? So that still is valid. So what kind of triangle have I created?
Right.
A right triangle. It's straight, parallel to the ground, and this is vertical to that, so it's going to be a right triangle. So part A just says write a function. S is a function of D. So another way to think about the word function is there's a relationship between two variables. So what is the relationship between these two variables? Yeah, it's the Pythagorean Theorem. They're in a triangle. This is a number here, thank God. So if I write, so which one's the hypotenuse? Good. So I get S squared
D squared
plus 1 squared, which is 1. Kick ass. So what's S?
Radical
Why do I have to put plus or minus? Because S is a distance. It's a length, right? So I need it to be positive, or else the plane has gotten sucked into some kind of vortex.
Would you keep D squared?
I love it. So, I don't love it, actually, but a lot of people don't take this personally. That so desperately does not equal that. Please, dear God. My Math 280 students do this, and that's when I actually cry. If you guys do that, I'm not going to cry, but I just want this not to be done. Because this is so desperately not true. Right? It's the same reason that, what's A plus B squared? Is it A squared plus B squared? Is that true? No. Why not? Because squares are based on multiplication. They're not going to play well with addition. Right? That's the bottom line. You have to write it twice and FOIL it to get around that shit, right? What are radicals? They are freaking powers, right? Powers don't play well across addition. Now, I don't care how you write your power. It still can't distribute to both. So we see this kind of thing a lot. X squared minus 9 equals x minus 3. No, it doesn't. No. And what I always write is, what's the square root of 4 plus 9? That's the square root of 13. And that's not 2 plus 3. Is the square root of 13 equal to 5? Is it? No. Okay, good. But that's worried there. I don't know, man. You guys see what I'm saying? You can't distribute a square root. So that's what it is. Right? That's part A. S is a function of D. So So part B says, I want to write D as a function of time, knowing that it goes 350 miles an hour. So D equals what? After 1 hour, how far is the plane gone? 350 miles. After 2 hours, it's gone 350 times 2, 700. So after T miles, it's gone, T hours, it's gone 350 T. That's part B. So now it says write S, which is currently a function of D. I want you to write S as a function of T, as a function of time. Well, how would you do that? The problem says use composition. And then people are like, well, what is composition really? It's plugging one function into another. Beautiful. So I know that D is 350T, and I know that S is square root of D squared plus 1, so what can I do with this? Plug it in. That's what composition means. Plug one function into the other. If I replace D with this, now S will be a function of T. There you go. So I'll know what this distance is, and I know how far my missile has to travel, so I can blow them up. There's a vacuum. Have you killed anybody? They were all bad. True lies. Use you as a human shield. All right. Maybe. The problem sounded horrible, and it really actually turns out it wasn't even that much. It's just that combination between how it's saying in English and a real problem and how it relates to the math that we do. Right, so it's still the same math we do, just plug and shove.
The numbers are a lot more friendly.
True. All right. Yeah.
51 of 2/6.
Oh, good. All right, cool. Yeah, these are neat. This is where you have to do that F of G thing backwards. You got to figure out what did they plug into something else. So G of X. See, what's the form of G of X? Something over something plus 4, right? So there's an outside function and there's an inside function. Let me do another problem real quick that's a little easier to see. So if I had this, all right, this will be nice and easy. What's the inside function? So if I call G of X, X minus 4, what's the outside function? What am I doing to that inside function? Cube root. So if I call F of X, little f, right? The cube root of X. What is F of G of X? So plug that in there, you get this, right? So that's what they mean. They give you a function with a capital letter. Very often that's used. Capital letter means it's made up of other things. And you figure out what did they plug into what to make it. And there are several answers that are possible. There's basically an infinite number of answers that you could do. But some of them will be stupid, like X plus 2, and that's actually X minus 6, and then stuff like that. You can find an inside function and an outside function. Now this is a little bit weirder, but still the form of it is something over that same thing plus 4. So the outside function is that form, because what's the form of this? The cube root is something. That's the form of it, right? So if the form of this was, the outside function is x over x plus 4, what did somebody plug into it? X squared. So if I plug G of X into f of X, I get big ass G of X. Right? That's the whole point of that section. What did they plug into what? What's G of X, the inside function? What's F, the outside function? If you're going to calculus, how many of you guys are going to calculus again? Several of you are hoping to. I'm hoping to. Right? If you get there, you're going to hear that very quickly, maybe the third week or so, depending on your teacher. Inside function, outside function. If they teach derivatives correctly, you'll hear that. Right? You're like, oh yeah, shit, this is what we're talking about here. Okay. Anything else from homework or practice test?
G of X equals X squared into X.
It'll become X squared, it'll become that. So I'm saying big G is F of little g.
I was
I got you. It's got to replace all the x's. My intention was not to beat you up. It looks like you have been defeated. That's true. Is that happening? At least I didn't give you the test today. Or 11, have you ever had a teacher that gave a test the Monday after spring break?
Yes.
Who the hell are you?
Good.
Give me a few more years, I might feel like I have to be that mean. If you don't show up, you can't take it. No, I'm not there yet. I'm not jaded enough yet. Yes?
Can you do 2.7 and 45?
Oh, yeah, thank you. All right, good. See, this is good. That makes me feel better. That's one of the problems. I'm like, somebody's got to ask the question here because it's a weird question, weird problem. Oh, and I got to tell them even and odd. How are we doing? All right. And just to warn you guys, I love this problem. And that normally means I might put it on the test or something. So it gives you this function. I heard you right? It's this one here. X over x plus 4. That's the one? Okay. And it says find the inverse. So what's the steps to find the inverse for this? Yeah, so right now this is y equals that. Switch them. And solve for y. Well, this is a good problem for me with y's and 4's. Alright, gotta write careful. So what the hell? This is where people freak out because they're like, oh, there's 2 y's. No, there's not 2 y's up there. How do you solve any equation for x? You get all your x's on one side, right? So that's the same idea. How do you solve for y? Get everything that has a y in it on one side. But what's the first thing I want to do? What sucks about this problem? The y plus 4 on the bottom. So what do I do with that? Multiply it. So I get
y plus 4x.
Now, if you're trying to solve for y, you want to get all your y's together. Because how do you solve any equation? You get all your variables on one side and the numbers on the other side, right? So from here, we're trying to solve for y. I get all my y stuff on one side, everything else on the other side. That still applies. Now, if I factor the x right now, it just keeps me right back to where I was. I want to get all my y stuff together. Because who am I trying to solve for? Y. So subtract xy. I get 4x equals y minus xy. Now, do you see what I meant? There's not 2 y's up there. There aren't 2 y's. What do I do now? Factor out the 1 y that's there. And then how do I get y by itself? Divide by 1 minus x, right? There you go. There's your inverse function. That's how you do any rational function. So you know I'm going to give you this exact kind of problem. Probably with like 2x minus 1 on top or something. That form, you're going to get that on the test. I'm just telling you that directly. Right. So you have to be able to do this to find the inverse. Yes?
Can you do 35?
Oh. If they ask you, are these two functions inverses? If f and g are inverses of each other, for example, like the cube root of x cubed, what happens here? Yeah, the answer is x because these two do what? So if f and g are inverses, what do they do to each other? And you're left with... So if they say, show me that f and g are inverses, plug one into the other one and see if you end up with x. They should undo each other. So take, and that sounds yummy. Again, that's that word you wouldn't use. So you take that whole x plus 2 over x minus 2 and you plug it in. So g of f of x, for example, if you want to do it that way, it would be, what's g? Well, that's gross. Let's do it the other way. Either way, doesn't matter. So if I plug g into f, it would be the whole g function, right? And then the whole g function minus 2. Like that. Gross. So I put g into f. So what do you do when you have fractions inside of fractions? you killed it. Right? I can actually multiply top and bottom by x minus 1. As long as I have two sides of an equation, top side, down side, right? As long as I have two sides to balance it out, I can multiply by the denominator and kill it. And at the end, you should get x. Because if these two are inverses, they should cancel each other. You should just end up with x. So they're not asking you to find the inverse. They're just asking you to verify their inverses. That's what you have to do.
Which problem is this?
35. Yeah. Okay. So that's plenty. Anybody not get their stuff back here? Came in late? Yeah. Sure.